From Transport Topics in Washington, D.C., this is RoadSigns. And now here's your host, Michael Fries.
Thank you for listening to RoadSigns, the podcast series from Transport Topics that explores the trends and technologies that are shaping the future of trucking. Before we dive into today's episode, we'd like to invite you to subscribe to Transport Topics, where you can receive exclusive access to our top 100 lists, quarterly magazines, and other news surrounding the trucking industry. To subscribe, visit ttnws/TT subscribe. You can also text TT subscribe to 571-622-0001 to become an official member of Transport Topics. That's 571-622-0001. In today's episode, we'll take a front row seat to view the future of the internal combustion engine, or as we refer to it as ICE. As EVs are rising in critical mass with the general public, it's easy to get caught in the new, while there's an opportunity to view the innovations of what we have already. During our last Transport Topics magazine event series, Spark, we've talked about the advances with the engine, as well as some inquiries about alternative fuels. Needless to say, there are some interesting perspectives. So for this episode, we'll ask the question, what is the future of ICE? To answer that question for this episode, we'll have Ryan Manthiri, project leader at Shell Global Solutions, to talk about Shell's latest version of the Starship project later in the program. But to start things off, we have Michael Grahe, head of operations at Navistar. Here's our discussion. Michael, welcome to this very special edition of RoadSigns.
Great having me. Thank you.
Glad to have you. I just want to go back in time. Last year in Las Vegas, Nevada, in the middle of the Las Vegas Motor Speedway, you were on stage unveiling the S13 integrated powertrain. And the comment that you made, where I thought was pretty profound, the best and last internal combustion engine international will make. That's what you had said about the S13 integrated powertrain. With that, that's a very bold statement. And as the company moves towards its goal of zero emissions, how does the powertrain align with that vision?
Yeah, so coming from the Navistar vision, where we say we want to accelerate the impact of sustainable mobility, we set ourselves a target that we want to have zero emission vehicles, 50% of new vehicle sales, zero emission vehicles by the year 2030, if the charging capacity is available, which is a very bold goal, we think. But at the same time, it means 50% of our portfolio in 2030 will be still internal combustion engines. So for us to have a highly efficient, reliable, and sustainable combustion engine is a key. And this is why we are working on the S13 integrated powertrain to bring this really, even for this 50% remaining volume, have a great solution. And when you are looking for the technologies we are applying there, first of all, the big thing is that the S13 integrated powertrain has been designed with SCR as the base technology already from the start. This helps us a lot of optimization. So, for example, we have no EGR cooler on the engine. So in a normal engine condition, 100% of the exhaust flows goes directly to the turbocharger. We have a fixed geometry turbocharger, which helps to reduce complexity in the engine and increases reliability. So we are really having put everything out of the toolbox, available technologies into the S13 integrated to have a great solution for the long tail of the internal combustion engine, but being there reliable and also sustainable and meeting and even hopefully at some part over-fulfilling emission regulations.
With that, as you said, that's a very ambitious goal of being 50% by 2030, and 6 months from now it'll be 2024, and that is just 6 years away. Are there any specific plans to incorporate things like dual dosing systems or 48 volt systems for catalyst heating into Navistar's future truck designs?
So for the initial launch, which we are in the middle of, we don't have dual dosing or 48 volts. Now, of course, as the requirements on the emission side continue and we are looking at different technologies, how to meet also future emission regulations, we are still testing and investigating the right solutions for the North American market. But one thing is clear: we always look there at, on one hand, the cost aspect. So how can we be cost competitive for our customers? How can we have the right performance? Because meeting tighter emission regulations, you want to still keep the right performance, but, and very important for us, to have high reliability, because for our customer, uptime is the key issue. Trucks have to be running, trucks have to be transporting goods, so the reliability is a key focus. And for this future emission regulation, we have not fully decided yet which technology path we are going. We now have stability on the regulatory side, looking forward with a 50-state hopefully regulation from 2027, and we are now working together with our customers to have the right technical solutions for this.
With that, just in the planning of these upcoming regulations, you have the advanced clean trucking rule. You also and also of course the EPA rules that have been in effect recently, and the NOx regulations that are still coming forth. Can you talk a little bit about, you kind of touched upon it in the beginning, but can you kind of go a little bit into detail just about balancing those engineering efforts when it comes to those particular solutions, and how will that look like? Like you said, it's going to be 2030 is that timeline for your goal. So within that 6-year period, how is that? How are those efforts looking?
The challenge, and I think every OEM has this at the moment, is that you basically have to work parallel on two technology streams for propulsion. One is the zero emission, and the other one is the internal combustion. Because as I explained before, the internal combustion is still quite a significant volume, so you don't want to let this just roll out. You also want to improve there, stay competitive there. Let's say, and how are we doing this as Navistar? And I think we have, let's say, several advantages. One is that the base engine, which we designed with the S13 integrated, is in the commercial vehicle industry one of the newest engine designed from scratch. So it has a lot of capabilities that we meet future emission regulation without dramatically redesigning the engines. The second advantage that we have as Navistar is we are part of the Traton Group. So we are part of a much bigger organization, and we have full access to the portfolio of technologies and capacities, engineering capacities worldwide. So we can work together there in the group to have regional solutions, but also to share technologies to find regional solutions. And how we are doing this is that's the third big advantage, that we are working in the group in what we call Traton modular system. So in a Traton modular system, this means that we have a modular approach to technical solutions. And the principles behind it are very simple. The first one is same need, identical solution. The second one is well-balanced performance steps and standardized interfaces, so that we can use different technology steps very clearly, and using this on a global scale. And by this, we can balance our engineering effort on one hand, working on the zero emissions, and at the same time working also at the internal combustion engines.
Being part of the Traton Group, as you had just mentioned, and as you just said, brings a wide array of ideas and upcoming innovations for your group. And in doing that, you spoke about standardization. Has that been a problem in the manufacturing of just engines in general, but before, I guess we can call it, the dying age of electric vehicles is coming? And have you? Has that been a problem just in the case of standardization of manufacturing? Just kind of balancing those engineering efforts?
So for us, can I say the approach is actually not standardization, but modularization. So the standardized interfaces and the well-balanced performance steps, we can actually have interchangeability of different modules, different components to come to solutions which fit our customer needs. So we can also always be very specific to the North American market and taking out of the modular system the components, the systems which are required to be competitive here. And this is also helping us a lot to be efficient on the manufacturing side, because with the standardized interfaces, we can tailor our factories to these modules, these systems components, to put them together as little building blocks to come to a complete vehicle. So this is helping us very much of driving this transition and be competitive if we are working on two technology streams for propulsion at the same time, the zero emission and the internal combustion engine for the next few years.
Well, thank you, Michael, for unwinding my confusing question. I guess I kind of just mixed up standardization and modernization. When it comes to this, there are a lot of pieces and parts to that. So thank you for that. Let's go off to let's switch to the to sustainability and the path to sustainability more specifically. And with that, what will that look like in the next 10 to 20 year period? As of course, as you touched upon, fleets balance those things such as total cost of ownership, and you have spoken about it before, previously about infrastructure. How does sustainability look for fleets?
Yeah. So on one hand, and that, let's say the easy part of this is that we are approaching the sustainability for the internal combustion engine to increase the efficiency and the performance of the S13 integrated powertrain. And this is also where fleets just can utilize this powertrain for the future as it's so highly sustainable. That's the easy part. The other one is, of course, the moving into the zero emission side. And there, the transition from our perspective, especially on the battery electric vehicle, will happen segment by segment over time. And the main driver for this transition will be the total cost of ownership. So where is the tipping point where it makes, from a business perspective for a customer, more sense to use a battery electric vehicle instead of an internal combustion engine? And let's say on a very high level, you can say it will start on the school buses, and we are already in the sweet spot of TCO for school buses. It will then very soon come to the medium duty trucks, where you already see the first areas where the TCO is achieved, and then it will come to the regional haul vehicles. From there, it will go on to the on-highway long distribution trucks. This will maybe take a few years more, and then it will come to the severe service. But it will be a transition driven by TCO, not by regulation. It's rather we need a stable regulatory environment to develop the technologies to meet the customer needs. The biggest challenge, I would say, at the moment in this transition is the charging infrastructure, because you need infrastructure. And I'm not talking always about the public on-highway charging, but also customers have to install charging in their depots. Charging has to be installed in certain destinations at warehouses. So this will take some time. It is the energy as such overall is there. It's maybe not always at the right place. So there needs to be a lot of investment, but all the support out there, it's there. We now just have to implement this. And I would say we are working a lot with customers on this transition, because what we learned so far is the customers who are looking at this, how they also modify their business model, how do they adjust their transport system, are most successful in this transition to zero emissions. The ones who just want to say, hey, instead of a diesel, I use a battery electric truck and run the same route and the same planning, they struggle a little bit more. So it's a joint effort together. We are doing with our customers together, helping them to support, to help them find the right charging solutions, help them in deploying and managing this charging infrastructure. So this is where we are helping our customers and where we're working on very strongly at the moment.
Well, Michael, it sounds like there's a lot of pieces and parts, especially when you talk about infrastructure. And from the comments you just made, sounds like it's somewhat of maybe an enthusiasm gap. And as you also mentioned, there's this transition is going to take time. To relieve those pain points and to speed up that particular process. What particular things have to happen?
I think just everybody has to work together, because it is not a simple question. Hey, is there a battery electric truck available? I buy it and I run it. Suddenly, the customer has to work with infrastructure providers, have to work with charging suppliers, have to work with new technologies where customers don't have really the long years of experience. Diesel engine, all the customers know it. They know the ins and out of a diesel engine, how to run this. With battery electric, suddenly you have a new technology. But we, Navistar, are here to help. So we are offering services to our customers to help them to find the right partner. We have partners that we can also offer to our customers one-stop solutions. And when they say, hey, can you do this for me? So this is a transition. We all have to learn. And now you can always take this example. When the transport system in North America went from horses to trucks, there was also a lot of anxiety changes. How do we, how should we build fueling station? But we have all the stables where you can feed the horses. So now we are in a similar situation, but looking back in history, the transition went quite well, went quite fast. And I'm predicting that it will also work here. And this is the strength, I think, especially here in the North America, that now we are in an implementation mode. So that the question if is gone, it's just how, and everybody's working together now to implement this and to move forward.
Well, it's pretty particular. It's interesting that the discussions that we're having about the internal combustion engine versus electric vehicles, it might be the same discussion that was had at that turn of the century when we were when the discussion was about horses versus fuel in cars. So it's the more things change, the more things ultimately are staying the same. We've been speaking with Michael Grahe, Executive Vice President of Operations at Navistar. Michael, it was a pleasure having you on this very special episode of RoadSigns.
Thank you very much. Have a good day.
Hello, Roadside listeners. Dan Ronan here from Transport Topics. I'm here to tell you about our new extended cuts of the Road Signs podcast. If you like what you learn here, I think you're going to really love this. So what is the Road Signs extended cut? Well, instead of ending the recording and saying our guest farewells, we're keeping our expert guests around for an extra 1 or 2 questions to gather a deeper, fuller picture of the influential topics in transportation. We capture that insight and convert it into a printable download that will help you navigate the latest trucking trends and guide your next business decision. Considering the easy, linkable, and printable format, you can keep the extended cut for your next big meeting, send it to your friends and colleagues, or pack it up for your next big conference. So how do you get the latest download? Well, it's real simple. Visit ttn.ws/extended cut. That's ttn.ws/extended cut.
Hey, Road Signs listeners. It's your man, Mike Freeze, here to tell you that the call-in lines are open. What does that mean, you may ask? Isn't this a podcast, not a radio show? You're correct, but we found a new way that you can call in and leave myself or my co-host Seth Clevenger a message. Leave us a message on new topics you'd like to hear more about, or ask questions you may have about the trucking industry. Give us a ring at ttn.ws/speakpipe. Welcome to the show, Ryan.
Thanks for having me on, Mike.
No, not a problem at all. The Shell Starship 3.0, it's a 3.0, so it's the third iteration of that initiative. Could you go back and just tell us about the beginnings of the Starship project and some of the initiatives that you set out to achieve?
Yeah, no problem. So the project itself, to understand the why, you got to understand where the sector sits right now in this whole decarbonization journey. So transport, as it stands now, accounts for about 35% of global energy usage, and of that, road freight transport is responsible for a third of that total. So if the sector is going to meet its emission abatement targets, transport is going to need to be a major focus area. And this is kind of why we launched the Starship initiative back in 2018. We intended it to be a material demonstration of how the industry can work together to drive significant reductions in energy usage and CO2 emissions.
With that, there's a lot of aspects of the Starship that seems very, very intriguing. One of them is the natural gas, of course, but there's also let's start from the in cab, to that most important aspect of the driver and how that will gel well. Can you tell us a little bit about the cab design?
Yeah, so the actual cab, the specific cab, aside from the aerodynamic features on the exterior, if you look at the in-cab devices, we designed it to be very driver-centric. So, safety features and improving operational efficiency is kind of top of mind. So features like the collision mitigation system that basically helps the driver avoid potential collisions. We've replaced all the traditional mirrors on the truck with digital cameras and heads-up displays. So you have basically a wider field of view. We've eliminated those blind spots, so you've improved the safety during this, kind of the tight cornering maneuvers. And then there's the predictive cruise control. So we have this look-ahead feature on the truck that basically analyzes the approaching terrain. It will automatically select the optimum gear and it'll adjust the speed of travel to provide basically your best fuel economy, right? So it'll set you up, and that's great because it takes into account, the driver experience level, right? So whether you're a novice or an experienced driver, it's going to help you bridge that gap.
For just being inside of that particular cab, the driver, as you mentioned, is a very kind of off the shelf driver friendly cab that's in there. I mean, you can have all of the innovations that you can, but if the driver's not satisfied in that, then I mean, I wouldn't say go all the waste, but it would be slightly depressing. but let's get into the technologies, just the energy efficiency of those particular technologies, as well as the lubricants. What are some of the improvements that you worked upon from the Starship 2.0 that is now in the 3.0?
So the truck is designed around this concept of freight ton efficiency. So this is the ability of the truck to move the maximum allowable payload using the least amount of energy. And to do that, we've kind of structured basically around four key components or pillars. The first of which it's a concept called lightweighting. It's commonly used in the automotive industry where it's a means of building vehicles that are less heavy as a way of achieving better fuel economy. So in the context of what we're trying to do with Starship, which is load as heavy as possible in terms of the freight carrying capacity, the real savings from freight efficiency is found at a fleet level. So we want to maximize the amount of freight moved per gallon and basically overall reduce the number of individual trucks that are required for the fleet's operation. So with these Class 8 trucks, they have, if you take a standard Class 8 truck, it has a gross vehicle weight of about 80,000 pounds. So that's inclusive of payload, tractor, and trailer. Therefore, if you want to go heavier on the payload, it means you have to remove as much weight of the trailer and tractor setup. So what we've done here is we've utilized lightweight components throughout the chassis, the powertrain, the driveline, and that even extends into the aerodynamic package as well as the tire selection.
Some of that, I mean, those innovations and advancements you made from the 2.0 to the 3.0, and especially when you were talking about just the weight efficiency that's a part of it. I mean, that's really you can really tell the difference in the fuel efficiency, I would guess, right?
The second key pillar around which the truck is designed is around reducing opposing forces, and there's two significant forces acting on the truck. The first is rolling resistance, and basically this is the force created by the repeating flexing of the tire sidewalls as it rotates under its load. So there's an energy loss there as the tire rolls through its footprint. And basically what happens is ultimately the truck's engine has to overcome that energy loss. So you're burning more fuel. So for the tire selection, we're using low rolling resistance tires across both tractor and trailer. And these are basically specially formulated tire compounds that are more resistant to heat generation and designed to minimize the tire deflection. And that's just one area because the tires play a huge part in that. The second significant opposing force in the truck is around the aerodynamic drag. And that basically occurs when there's a force that's created by the air striking the front of the truck. And if it's not balanced by an equal and opposite force on pressing down on the rear of the trailer, then you get this drag. And depending on how big that gap is, the more significant the drag. So we get around that. If you look at Starship, you notice it's a very custom cab, that way, a very unique looking cab. So that's a lightweight aerodynamic carbon fiber cab that's significantly lighter than your traditional box-shaped truck down there on the road. Alongside of if you go from the front to the back of the truck, you have, just as you exit the cab, the front of the cab, you have these automatic gap sealers that basically deploy panels from the back of the cab to cover the tractor trailer gap. And the purpose of that is when the truck is moving at highway speeds, we ensure there's smooth body lines, and then the airflow sticks to or hugs the body of the truck as it transitions from the cab to the trailer. And then along the sides of the trailer, you have these full length side skirts, and that's there to minimize the airflow underneath the truck. And then just rounding it off at the end of the trailer, you have a custom bow tail, and that's basically designed to reduce the drag that's caused by the low pressure wave created by behind the trailer as the air exits the rear of the truck. So all of these features working in unison, it reduces our coefficient of drag. It sits around now. Starship has a CFD of around 0.25, which is significantly lower than the average truck on the road, which is around 0.6. So what it effectively means is, Starship has an aerodynamic drag that's more than half that of the traditional truck on the road. And all these two factors, in addition to the weight stripping, have a significant impact on the fuel economy of the truck.
Yeah, that's one thing I really would like to talk about. The fuel economy. It's if you look at it at face value, for some people, they just compared to what they're driving, of course, it's a slight difference. But however, getting that fuel efficiency and getting the other advancements of the technology that you just mentioned, I'm pretty sure that's what you were out to achieve when you started the initiative. But other than some challenges you have faced, I mean, was there anything that was coming from left field when you were doing these runs? Was there anything unexpected, good or bad?
I think the most significant challenge we had during even the build and the launch of the truck was planning and executing a run in the midst of a pandemic, because we started the build in towards the end of 2019, and COVID hit in 2020, and we basically continued with the build. But having to operate in that bubble, especially for the coast to coast run, I think was very challenging for the team. In saying that, though, when I look back at it, although COVID just caused significant delays, in hindsight, it probably helped us with the shakedown testing and the actual real world road test that we did on the truck, because we then had more time to kind of fine tune our setup, to dial the truck in, to get a good feel for what worked and what didn't before we actually attempted the run. So pros and cons to that, but I think that was the most challenging piece of the world. Yeah.
And that from the 2.0 runs, we're now at the 3.0 stage. In which I had mentioned in the beginning, the partnership with Cummins and its X15N engine. Could you tell me about just those partnerships and how they've been helpful and how they will be helpful for this upgrade of the Starship?
Yeah, so obviously this is going to be the third iteration of the truck, which is basically being developed under the project banner Starship 3.0. We did a soft launch at ACT Expo in May this year. In terms of the actual partnership, this truck is going to be powered by Cummins X15 natural gas engine, along with other freight ton efficiency promoting technologies. I kind of gave you a feel for that earlier when I was talking through some of those, but it will run on Shell renewable natural gas, which is currently commercially available, and it will be utilizing Shell's Rotella low friction lubricants. So The build should be complete by the end of August, and we'll aim to execute a demonstration run around September this year.
Oh, okay, okay. What are some of the things that you want to achieve with the 3.0 that you have not achieved with the other iterations?
The Starship platform is really there to kind of evolve with the sector, and it is meant to mirror the transition that's happening in the transport sector. So you saw with 2018 and 2019, we were utilizing a diesel internal combustion engine to kind of showcase still the significant, energy savings and emission reductions that could be had just by using what's currently available. Where we sit today, because of the infrastructure and the maintenance platform that's now available for natural gas vehicles, we're at a stage where it just made sense to transition to that. Not just from a total cost of ownership perspective, but also from an environmental standpoint. So with renewable gas, effectively because of the offset you get in terms of running with a much leaner, cleaner fuel, and the fact that with RNG, it's basically being produced from methane, and the methane is coming from the decomposition of the agricultural food or waste or wastewater essentially. Because of that, you're capturing all of that methane, you're redirecting it away from the environment, you're repurposing it as clean, green energy. And this is where that carbon neutral or that carbon negative claim comes from. And essentially, natural gas is a pretty fungible fuel source. It can be stored as a compressed natural gas or a liquefied natural gas. So it's a very versatile fuel. So in the context of Starship, this was a logical transition for us and the next step for the project.
Ryan, I have a few more questions for you. One of the things, we had mentioned the partnership with Cummins, but also, the Shell renewable natural gas. Could you tell us more about the work you've done with that, with the Starship, as well as other lubricants?
So we talk about freight ton efficiency being the guiding principle of Starship. So the engineering design choices and the technologies featured on the truck are in aid of this. So at the heart of Starship, you have its powertrain, which features Cummins' next generation 2020 X15 engine, and it's paired with an Eaton Endurance transmission. And this serves as the heart of Starship. So effectively, then that makes the lubricant its lifeblood. And for the purposes of what we're trying to do, which is go as heavy as possible in the highest gear using the lowest engine speed, you need a lubricant selection across the powertrain and the driveline that's going to withstand this kind of heavy duty cycle. And in the engine, we have Shell's Rotella T6 Ultra 5W30 engine oil. It's an FA4 fuel efficient lubricant. It's got a lower high temperature, high shear viscosity range. So that gives us the improved fuel economy, and it gives us protection at the increased loading. Similarly, on the transmission, we have Shell's Spirex S6GX ME 75W80. This is a fuel efficient long life gear oil. So it's also designed for heavy duty gearboxes. So you really need a comprehensive lubricant package across the entire truck's powertrain to provide the necessary protection and efficiency that's needed to kind of go as heavy as we're going.
One last thing, I just thought about the statement you had made about decarbonization in the larger sense when you're talking about the effects of climate control and climate change, and as well as putting these new technologies in a place where it makes sense. In a large scale, you have EVs that we have an infrastructure that we're working on, and versus natural gas where we have an infrastructure in place, and there seems to be much innovation toward that end as well. And we all know the EVs are coming in and they're going to be a part of our future. But where does that future lie in with the natural gases and alternative fuels?
Yeah, I think it'll be a mosaic of solutions that help the sector achieve its emission abatement targets, right? So diesel will continue to be a prime energy mover for the next few years. But now you're seeing natural gas, the infrastructure and the maintenance infrastructure coming online. So the security around the supply for these low carbon fuels are improving. So the sector will begin to scale these solutions rapidly. So you'll see natural gas and hydrogen take a more prominent role in that transition. I don't think it'll be a situation of one replaces the other. With as soon as hydrogen comes online, I think natural gas will still continue to play a significant role in helping the sector get to where it needs to be. If you're looking at it needs to, I mean, if you're considering where it is right now, it needs to realize an 80% emission intensity reduction in the next 30 years. That's a very aggressive target. And then you take into consideration what the global fleet looks like right now. There's a lot of legacy assets, primarily diesel powertrains out there. So what do you do with that? You can't just have every fleet owner and operator change over. They don't have the capital to do that. So there is a transition period that needs to come into play to allow the fleet owners and operators to change over their fleet gradually. And that's why you see natural gas will take a more significant role now, and even leading into the future.
The world of decarbonization is definitely a space to watch. We've been speaking with Ryan Manthiri. He's the project leader for Shell Global Solutions, and he is also the engineer manager for the Starship project. Ryan, it was a pleasure having you on this very special episode of RoadSigns.
Thanks for having me, Mike.
Did you know you can ask Alexa to open Transport Topics? In just 1 minute, you will hear the biggest trucking headlines of that day. Be prepared and start your morning off right with Transport Topics.
Before we close, let's take a moment to revisit our original question. What is the future of ICE? A big thank you to our guests, Shell's Ryan Manthiri and Navistar's Michael Grahe, for joining us for this special edition of RoadSigns. With the announcement of International's S13 integrated powertrain last year and Shell's Starship 3.0 initiative, there's a bit of enthusiasm for the engine component, and it's also a nod to the realities of the newer innovations, such as electrification. When Grahe announced that the S13 will be the last internal combustion engine product, he expressed that while the era of EVs is brewing, there is still room for improvement for the old guard that will still bring efficiency to fleets. The work that Manthiri and his team at Shell has accomplished with the Starship 3.0 notes that there is a bright future for alternative fuels. Both examples show that with the hype and excitement with the new does not mean the exclusion of what we already have. In fact, we have the chance to improve it. In doing that, the future of ICE will rise as much as the dawn of electrification. You can still listen to the Transport Topics magazine event series Spark by registering at ttnews.com/TTMES. If you enjoyed this episode of RoadSigns, please let others know. Rate and review us on Apple Podcasts, Spotify, and wherever you listen to podcasts. Feel free to reach out to the RoadSigns team on Twitter at TTRoadSigns or reach me at Michael V. Freeze. You can email us at share@ttnews.com. We'll read them and respond daily. Also, let us know how we're doing by texting TT Survey to 571-622-0001. And of course, we'll be back in 2 weeks with a new episode of RoadSigns. Until then, I'm Michael Freeze. Thank you for listening.